information. Let's get started, okay? I think she may
Okay.
just watch video. Since
Okay.
she's in Taiwan, it's probably 3 a.m. in the morning.
It's 6 a.m. right now for them.
Yeah, very early. But anyway, let's get started. Okay, last time we talked about some of the bit level operations and data type, but today we continue the data type. And then today we talk about more about a compound data type, okay, instead of just the basic integer characters, those kind of things. So there are fundamental data type, integer, floating point character. These are what we covered last time. Today we may
Yeah.
cover some of these.
Okay.
So fundamental data type also called primitive data type, okay? In Java, we call it primitive data type. They are integer, float, characters. Derived, you have array, pointer, structure, and UMU, okay? So this is different from Java. Java do not have a structure, do not have pointer, only array, okay? And then they have a string and class. But right here, there's no string and class. So data type, compound data type is a little bit different in C language than Java. So integer data type, you have char, that's 8-bit, okay? And then you have short integer, that's 16-bit. You have integer, that's 32-bit. And these, you have the signed and unsigned. Okay. And you also have the long integer and the long integer, signed or unsigned. Signed or unsigned determine like whether your data is filled or positive or with negative. Okay, with negative, you use two's complement format.
Yeah.
So that we talked about it already. And the range, okay, is we are okay. Floating point, you have two types, that's double and float. 32, this one, 32-bit double, I think double maybe is 64-bit. And then there's a long double. This one can be 10 byte or 12 byte, okay, depending on the machine. So, okay, these are the float double and long double. So character, you use a single quote like Java, okay? And then double quote for string, but we'll talk about string later, okay? And then C language has qualifier or modifier. 4 types of the qualifier. Size qualifier is including short and long to make a data type longer or shorter. Sign qualifier that you have signed and unsigned.
Yeah.
And sign, if you don't write it, it's okay. Sign, you don't write it, it's signed. Okay, you write it, it's okay, but if you don't write it, it's also okay. Then you have constant qualifier. Constant is you don't change the data, it's not final. Here it's called constant. CONST, okay, constant variable. And then you have volatile variable. Volatile variable is new in C language, okay. This one Java do not have the volatile variable. Okay, so these are different C languages data type qualifier to change the data type, okay. So size, you have long, short, we know, okay, this one, okay. Sign, you have sign, unsigned, we talk about it already. Constant, we talk about it. Essentially, C we have to final, but in C, you write constant, okay, means no change. Volatile variable is declarable whether the value can be changed by some external source outside the program or not. Okay, so volatile means that you create a variable to be volatile and it can be changed by outside. Okay, can be changed by outside, but this, I believe, right now, very rarely used. Okay, very rarely used. But if you write the volatile integer or integer volatile, that either way is fine. Okay, but I think nowadays nobody writes this. It's unsafe and no such need anymore.
Okay.
So proper use of C volatile keywords is actually sometimes memory mapped peripheral register. So this one happen only when you write some program for some embedded system for some driver cars. So your printer, something that need to directly write to certain memory, then you need to make it volatile. You directly write to the variable, that's actually something like that, okay? And then some global variable modified by interrupt service routine that you need it. This one also is an I/O process. When you write subsystem program, you need it. Okay, so this one, we just talk about is a volatile keyword, and then you will learn it when you learn the so-called computer organization and assembly course. Okay, you may learn it from there. Okay, that's the volatile and different qualifiers of the variables. Boolean type, we talked about it already. Boolean, you actually have bool type. Okay, but bool type is not born in C language. You actually need to use include standard bool.h. And that's happened only on C99 and above. But nowadays, because the compiler already so new, so everyone will come with this one. So we just directly use this is okay. But C provide type define. Okay, let's look at type define. Okay, this is starting of a program, and then as we say, they may be a long integer, right? But you want to use a long integer several times. So sometimes we use a type define long integer as long integer. That means LLI is a long integer. So here you may have a long integer a equals 3. And you print it. I think this one you can put a long. Does that make sense?
Yeah.
So in a way, you can define a data type using a different data type, and you put the older data type here, new data type name right here, and semicolon. This one is change the data type. So let's try another one. So you may have a you may define the Boolean type using integer. And then you may need to have some constant. So there are two ways you do constant. One way is you do constant integer 1 equals 1, constant integer 0 equals 0. Okay?
Yeah.
And then you assign integer b equals 1. Okay, it come out with 1. So that's define of the constant, but sometimes say you have the integer boolean, but you want to have a true or false. Another way to define a constant is using macro. So macro usually we use a capital. Okay. So this is pretty simple, but here, as you see, instead of saying a equals lowercase 2, there's no such a thing as lowercase 2 right here. So you use a macro 2 defined as 1. So what will happen is like before compiler compile, the 2 will be replaced by 1 right away before the compiler work. So macro is different from constant. Constant is you really reserve a variable, say 1, and you put 1 there. But with macro, define macro, do not reserve a memory. It directly replaces this variable, this word in the C language to the value of 1. So when compiler work, it actually directly change this one to 1. There's no memory being stored in the variable true. It just do macro change, macro update. And that's happening in preprocessor. So before your compiler work, they will replace this variable right away. Any question?
No.
Okay. So this one is when you do Boolean and you don't want to use a standard Bool, then you may need to define your own true or false, right? But if you include it in the standard Bool then you will have true and false that you can use in lowercase. Okay.
Yeah.
So let's try this one. Or 1 the C, okay. Okay, this one I include standard board edge. So then I can use the bool, okay, A equals actually 3 greater than 1. Okay, so with this, you already have the constant of the true and false in lowercase that you can use. Okay, so you directly run this one. You got it because I used the standard board edge. So nowadays we encourage students to just directly use the standard board edge. Okay. But here we define what's called type define, okay, and also give you the idea of what is a constant and also the macro definition, okay. And there are some other type of underlying bool type, okay. I think that's too much, okay. I don't want you to remember that those garbages. Nowadays nobody use that, okay. And then you have greater than the stand equal to, okay, this is similar to Java, so we don't repeat it. These are okay, then. Okay, up to here. Next one, before we go into the character types, let's go to see there's a homework in chapter 2. Talking about you have 10110001, how you actually type this one out. Okay. How you print this one out. That's a homework, but you haven't worked on the project yet, okay?
Oh. Mm.
We finished the chapter 2, but you haven't finished the chapter 2 homework project.
Oh, okay.
In a way, I don't remind you anymore, okay? You are a college student, whether you like to work on it or not, that's up to you. Okay, here we got a program. We want to print out the contents of the every bit for available. So let's see, let's assume that we have available for integer, let's call it char A equals it doesn't check the underlines for some reason, I don't know why, but. So this is a binary number that is so many bits, and we want to print out every single bit, okay? So what we would do is we may create a okay, a one only mask. Okay, then we do follow. Okay, so we actually work on the bit 8 times. Every time we actually let it end with a mark. So if it is 1, we actually print 1. If it's 0, we print 0. After that, the A will be shifting to the right for 1 bit. Shifting to the right, so this is shifted to 5. So what happened is that you have 1 0 1 1 0 1 0 0 0 1, and then this one is a 1, so you print 1, then the data will become 0 1 1 0 1 0 0 0, and then this will print 0, and then you shift to the right, you become 0 0 1 1 0 1 0 0, and print a 0, and then you shift. Okay, keep doing that. And by doing that, you should be able to print out your bits. But it's in reverse order because it's in reverse order because your data is getting out from the right side. So this one is actually your first bit. Okay.
Yeah.
So what you can do to modify the order would be, let's do this. You can change it. To compare the left side bit instead of the right side bit. And then you shift to the left every time. Instead of shifting to the right, you shift to the left. Then you got the right order. Okay, then you got the right order. Any question on this one?
No.
Okay, so this one is the bit level operations. Okay, bit level operations. How you print out your every bit. There are still a different way of doing it. Okay, there's still a different way that you can do it. We'll talk about it later. Okay, when we talk about S print. F. Okay, we talk about S print F. Next one, let's look at the character type. Character type is based on the ASCII code for storing your text. Sorry. This one, I think we talked about it before, so I don't waste our time. You need to remember the ASCII code location, okay?
Yeah.
So it declared char C, but char C is actually an integer, a-bit integer, signed integer. So usually when you use for character, you may want to use unsigned char. Okay, let's do unsigned char. Okay, this available. A is a 8-bit unsigned character, but we say ASCII code of the A is an integer. If you use it as unsigned integer, you will print out as an integer format. And then it will be print out as a character as well. So we will be able to build your ASCII table by doing this. Oh, I have a typo, sorry. Okay, got it. These are the ASCII code. Some of them cannot be printed because you actually don't know. Okay, let's actually use the equal as well. Let's do it. When you have an equal, it doesn't stop because you will go back to 0 once you pass it. So the loop never terminates. So that's actually wrong. Okay, so you cannot do equal. And the window doesn't respond. So it actually is a overflow problem. So that actually I just demonstrated your loop is becoming an infinite loop because you do that. Okay, but if I must print the 255, how can I do? If you must print the 255, then you do not use the A for it. You actually change it to unsigned integer. And then you convert it to 8-bit. Convert the I to unsigned integer char. Okay, then your 255 will be able to be shown. And the loop won't go into problem. Okay. Because right now it's no longer a char, it's already a integer, so it's longer form. Permission not allowed. Oh, so for some reason your program need to be deleted. Somebody's still using it. Okay, somebody still in. Let's actually cancel. Let's actually go outside. When that happens, means that somebody's still using it. You can delete it. Let's go to here. Let's delete it. Somebody's occupying it. So the process that we run let's actually quit it. And let's delete it. It didn't allow. Okay, I'm sorry. So what can we do is, let's do it this way. Let's actually change the name to alphabet 2. And the alphabet would be dead whenever you run, open the Windows. The alphabet process will automatically be deleted. Okay, so that's all. So let's run it one more time. Okay, now 255 show up. So they are boundary condition you need to check, okay? And then you need to make sure your program work under every condition. So this one show you like the what type definition and change of a type in the language, okay? So CHAR in itself is a factor, is also an integer. Okay, it's also an integer. You can use it to do arithmetic operations. And char is a 8-bit signed integer. It can also work as a unsigned. You can put unsigned sign before it. Okay. And then they have data type for integer A underline T. T is type. So this is unsigned integer A bit. These two are the same. These two are the same. And why they invented this is because that in the old days, the compiler is very bizarre. Nobody knows that it's an 8-bit or 16-bit character. So instead to guess which you are, so they just say it's a integer 8-bit type. Integer 8-bit type is a integer 8-bit underline T. Or you use you unsigned integer 8-bit T. Okay, let's try it. So this is the same program. Let's copy it to alphabet 3. So instead of unsigned, using unsigned character, you use unsigned integer type A. A-bit unsigned integer. Okay. But somehow they don't recognize this type. Okay, then that means you need to use a standard. Okay, you need to use a standard integer library. stdint. So std is a standard library, standard integer, standard bool. Okay, then you will have this unsigned integer 8-bit that you can use. Oh, I'm sorry. This one is Python's comment. So any questions so far?
No.
Okay. So that's if you need to use the standard integer type. So they are UINT 8, 16, 32, 64 different type of the type. Okay. So if you don't like to use a character integer, long integer, those kind of symbols, you can use an unsigned or signed integer, 8-bit, 16-bit, 64-bit. In this way, the advantage is that you always know that how many bits you are dealing with, no matter what compiler it is. Okay. The disadvantage is the name is very bizarre. Okay, very bizarre. I prefer to use the character as the old way. Okay, but sometimes you may see program having that. Okay. Next one is array. Okay, this one we'll talk about array. Array in C language is different concept from Java language. Okay, so Java is you have something we call it reference. Okay, so you create an array A. It really is the array A address and A pointing to the location that you store the data in the dynamic memory. Okay, so this let's say address is A1, B2. You store A1, B2 right there. And then indirectly access the memory. This is C language, okay. This is Java language, I'm sorry. But C language is different. C language, you have A2. It is a compound data type. So what happened is like, let's assume that you declare integer A2. It would reserve two locations for the array A, and A would be the starting address of first variable. So there's a A0 and A1. You would directly access the memory, okay? Instead of indirectly access the memory. That's right, okay? Okay. Number one, integer is not a class, not a reference type in C language.
Yeah.
So there's no such thing as a.length.
Okay.
So you basically don't know how long it is. So what you can do is you define an A length and you put a 3 over there. Is that okay?
Yeah.
So there is no A length. So you need to define the A length by yourself. We call it A length. So I from 0, I less than A length, you print out A, okay. So this actually keep you a variable A. There are 3 variables over there, A0, A1, and A2. And you can store data into there, but right now you do not store any data in there. So let's print it. You got 3 0 in there. Okay. So this one is that you create 3 data, but if you want to create 3 data on it, directly assign value to it. Is that okay? That's actually okay. Okay.
Yeah.
So that's the array. But they are not memory, they are not a dynamic memory. They are stored in memory with the address. So you say that give me the alias, this body of A. A is the address of the starting address for the first variable. So body of A, you will get the first element. You got a 2. Okay. And then
Yeah.
you say print. Body of A plus 1. A is the address of the array. And you do body of the A plus 1. And let's copy one more time. You print out these 2 different values. What happen is, okay, you do create a memory. How come so I cannot write it? Something wrong. I cannot write it. I'm trying to use my pen. Okay. So you create a memory, you put 256 over there, but A really is the address of the 0. A plus 1, you go to the 1 location. A plus 2, you go to here. So A, you would create a array address. And then starting for the value of the 2. But A plus 1 will go to here. A plus 2 will go to here. You put the body mark, you will get the value of that address. So you have 2 ways to print out your array. One is using this, one is using pointer notation. Any questions so far?
No.
No? Okay, that's actually a array. And there's no way that you actually use eta length, okay? So you have to know it. This one is actually static array. So that means that when your program created, you will have a memory for the A array forever, okay, in your memory. You will always have that. Now let's look at another one. Let's actually look at We call it array 2. So this previous one it is actually a memory. It's actually a static memory. Now we want to create a dynamic memory. So we say integer body of A equals we memory allocate how many actually size. We allocate 3 size of the integer and dynamic create. So this one equivalent to new integer 3 in Java. So it's a runtime. You create a memory in the heap, assign it to A, and you print everything. But when you finish, you have to do one thing. You have to do read A. Then your A locations are returning to the memory pool. Okay, this is called dynamic memory. Nowadays, only very advanced programmer would use this dynamic memory. Otherwise, you use the traditional static memory is good enough. Dynamic means that you can save some memory, but you do need to plan ahead to know about what memory you needed. And once you finish, you need to return them. Okay, use this one, you need to include standard library batch. Okay. If you want to call the memory allocation and allocate memory allocation. Okay. You assign, but you do not get a value. That's fine. Okay. Then you do okay, assign some value for it. Any questions so far?
No.
So this give you the idea of what is dynamic memory. Okay. Dynamic memory is whenever you do use a new or you use this kind of memory allocate, they will create a memory in the heap. And then once you finish, you need to return to the memory pool. Okay. And then in Java, everything is dynamic. Okay. In Java, everything is dynamic. In C language, they allow you to use a static array and a dynamic array. They are different. Okay, they are different. In C++, similar to C, they also allow you to do dynamic memory and dynamic array and regular static array. Okay. But you do need to know about the differences. Now, next one, we are going to talk about characters, string. So string is a special kind of array. It's called array of characters. But array of character is not the same as the string directly. These two are different things. Okay? These two are different things. String and array of character are different things. So let's look at the differences. Okay, so we create 3 array of characters. But the first one do not terminate with \0, so it is not a string. Second one finish with a \0, that is a string. Third one is in string format. It didn't put a \0, but it will automatically give you a \0. That's also a string. So these are the B and C are the 2 ways that you can write your string. So you see, when you print out A, you actually have more data. Why you have more data? Because you have an A finish, you go to your B right here until you finish with this one. So actually, it keep printing until you see a \0. So that's not a string. That's actually an array of character. But because the memory is the continuous, so A finish, they continue to print B until they see a \0 to terminate the string. So A become A, B, C, D, and then A, B, C. The second A, B, C is the B's memory. And B is a string. B terminate with the \0. So the \0 is always needed for a string. If you do not have a \0, then we call it an array of character. It's not a string. If you have the \0, then you can be treated as a string. And when you print the %s, you were looking for a \0 to terminate. When it will terminate, it will depend on whether nearby memory there is a \0 or not. Any question so far?
No.
And \0 is a byte of the data with 0, 0, 0, 0, 0, 0, 0, 0, 0, okay? And that will terminate your array. So the concept of array and string in Java and in C is quite different. Okay, you need to know what you are talking about. So this one is the array of characters and the string. And of course, you can print out the character by character. So you can print out each character because it's an array of characters. You can print %C to print out each character, okay? Let's look at the string more. You can also use a bracket without putting the 3 or 4 in there. This one is also an array of character. A is an array of character, but how long it did not specify. And how long will be specified by the data that is assigned to you. Okay, so this is effectively the same as A3. It will create a static memory for ABC characters. This one DEF. This one assign A's memory address to B. So B will be pointing to the same array. Okay, any question?
No.
And you can use dynamic memory to allocate 1 byte for it. Okay, this is also creating a dynamic memory. Okay, but we seldom do this anymore. But can you do a pointer equals this? No, this is wrong. It can only be stored with the memory address. So you cannot directly assign an array to a char pointer B. Okay.
Yeah.
So this one is the ages of array of character type. This one is the body of the character type is a character. Sometimes this A bracket and the pointer A can be used mixedly, but they are not of the same purpose. Okay, they are not of the same. Sometimes they can use mix. Okay. And you can initialize the string by doing this. It's fine. You can use dynamic memory or not dynamic memory, up to you. Common error with string. This one you must put a 6 over there. Okay. You will return an R pointer type. It accepts an array, but it doesn't accept a string. Okay. So this is okay. This is okay. But this is not okay. Next one is the input. Input, you may want to get a character, you may put a token using scanf. You may want to get a line. So this one getting the character, this one is like next in Java. This one is like next line. In Java, okay. Let's do it. Okay, so this one enter a chapter and then store it in C. We use the scanf every time scan in a character. Now that because we have input, we need to use a terminal. Okay. So that we in a single character and then print it. So when you modify this variable, you want to input it, you need to use the address of it to scan in so you can modify the variable. Okay. Now, if you want to enter a longer format of the string, okay, let's do this. Just using enter a token. Now I want to enter my name, but I don't know how long it should be. Because I have no idea how first name should be. So I put a 2 by 56, okay, to be long enough to get the data. Then I scan in the string. Then I print out the first name. So here I do enter more character, but it only take the first string into there. That's token, single token. So this one is the same as the next function in Java. Any question?
No.
But sometimes you want to have your full name, not just the first name. Then you use a get as tree. Okay, similar to next line in Java. So what happened is like I enter every child is good. So this child is good is used for the next function. Okay, it doesn't wait until I enter the new line. So the data got fit through. Okay, data got fit through. So to solve the problem right here, that's H2. Let's to consume all of the remaining characters. Is that okay?
Yeah.
So these are something that you didn't learn when you need the input, okay? When we talk about how to read the input into strings. So you have three functions: get a single character, get a token, and get a line of string. Okay, that's what I want to say. That's console input, how you input your data to your program, okay? Output, you use a printf. The opposite, you have formatted printf, you have put s is to print. So this one is the same as your println. If you put s, okay. This one is formatted print, okay. But anyway, we usually just use a printf. Okay, next one is mesh library. Mesh library is the mathematical operations that you need, okay? So in C language, you use a mesh.h. In C++, you use a C mesh, you still can use the same library in C++. We'll talk about this later, okay? But at this moment, you know that you just include a mesh.h. And this mesh.h is including your ABS function, your rounding function, your seeding function, your power function, everything that in Java or mesh. Everything in Java you use mesh that something is roughly in mesh.h. Any questions so far? Except the random, they don't have random.
No.
Hmm?
No questions.
So this one is a polynomial function, and to calculate its derivative. Let's try this one, okay? So usually you can directly include std io.h std standard library h. These are commonly used functions. So sometimes, even if I don't do anything, I just include this for. Okay, because it's like no-brainer. So we'll define a polynomial function. This function is called poly. So this poly would have a coefficients array and a value. So it's a poly of x. Okay, defined as a certain function. So this A0, A1, A2, A3, A4, it actually is A0 is A0 plus A1x plus a2x squared. That's the polynomial function we talked about, okay? Okay. So right here, we actually we do double poly. Okay. So we have a0 plus a1x plus s squared times a2. We're going to evaluate this one, okay? We have C length, the length of the coefficients. So we do for integer I equals C length minus 1. I greater equal to 0. I increase. Sum plus equal. So this one is x plus 1 squared.
Okay.
This one's the s cubed minus 1, okay?
Yeah.
We calculate polynomial of 1 and the polynomial q of 1. Okay, this one is 1 plus 1 squared. This one is 1 cube minus 1 cube. Okay. Okay, any questions so far?
No.
So this is calculated polynomial. Okay. Next. Next, we are going to take the derivative of a function. Okay. Derivative of the function is take limit h approaching 0. F of x plus h minus f of x divided by h, right? That's your derivative. Is that okay?
Yeah.
So this is h. We also call it dt. dt is a very tiny step.
Okay.
Okay, so this is a function a little bit, it's just calculated difference, it's not derivative. Okay, let's actually do it in our new way, okay? So we need to have the polynomial, we also need to have the length. Then we need to have a double x. Then we need to have a actually integer step size. Okay. So double the dt will be equal to tiny number called dt. And you got a function polynomial called coefficient f. Okay, then solve this function and then you do this. Okay, so you do double polynomial of x plus h. Okay, double polynomial okay. So you got two values. One value is p of x plus h. You need to minus p of x divided by h. H is dt, okay? Then you should return your p. Then that's your derivative. As long as your h is small enough, okay? So here that's actually defines that pretty small step. Okay. Don't put an S there. Okay, now this few number, let's actually do this. Okay, it's too fine. Let's actually create a little bit too big. Okay, let's actually copy this one to poly 2. Okay. Okay, let me keep poly 1 without this. Let's delete this derivative part. That's too much. Okay, keep this one as poly. Okay, then go back to poly 2. Poly 2, we actually have the PQ, that's fine. Step fine, double fine, but do not use these two anymore. Let's delete them. So we have derivative and polynomial since function, okay. Now we evaluate a polynomial function. Okay, so we already have the polynomial like this. Okay, let's do this. Okay, let's do. Okay, let's use a 1,000 point. Every time use a 1,000 point. So the derivative point is even smaller, but the x advance is actually a little bit bigger. Okay. So let's do print. Okay, so this one print out the polynomial x. And let's print now. dp dt. So you print out the polynomials value and also the derivative for it, okay? One starting point. So it's correct, right? So we increase and then we need to go to 1. 1 should be 4. It's almost 4 for the derivative. Is that okay?
Yeah.
So this one can calculate the derivative. So I'm showing you how to use your math to create a function, polynomial function, and taking derivative for it. You can also calculate the integral. Okay, and C language is very good in modeling this. And in AI, you need to model all kind of mathematical functions. So you need to learn your calculus and then put it over here, okay? We did not use the sine function and also the other math function yet, okay? But
Yeah.
that's in the mathematical library. Let's use don't call it poly2. Let's actually use the sine function and take the derivative for sine.
Okay.
Let's copy this one. Pause us. Sine function, okay. So this one we no longer use a poly. Let's delete this. Here we need to pass a function into here. Let's call function f. So f is a parameter. It's a function to a double value. And you pass the x to there, so you do calculate f of x plus dt minus f of x divided by dt, that you get your derivative, just like the poly, okay? Except that right here, we are using a function. The parameter is no longer a coefficient array. It's a function of double. Is that okay?
Yeah.
And then right here, we don't do poly. We do sine of sine function x. So this one, let's call it sine of x. Let's do 2 pi. Okay. From 0 to 2 pi is actually one cycle. And then every 1/1000, you will update your data. And you start it from your sine 0 to sine 2 pi. And you take the derivative for it as well. Let's do this, okay? Let's do this. Let's actually copy it. Cut it. Paste. Let's just separate them. Okay, so we got two functions. One is sine x, the other one is d sine dt. Sine function for 2 pi is like that. D sine dt is a cosine function, right? Okay, whatever. Does that make sense?
Yeah.
So let's go on. So sine function starting from 0 to 1. Okay, it actually has 1,000 point. Too many point. Too many point. Let's drop a digit. Okay. Drop a digit just because that there are too many points. We cannot read it. So let's see. So dp dt starting from 1.0, that's cosine. And become negative. And then go to -1. And then coming back to positive. And then go back to 1 again, that's cosine. Does that make sense?
Yeah.
So this one I show you how to do derivative for polynomial and for sinusoidal function. So basically, all kind of function we can use the same derivative We can also calculate the integral for it, okay? If we have time, okay, if we have time. So that actually what I want to say is there are tons of library in math you can use. We actually show you using sign, and we also teach you how to get the derivative for it, okay? Next one is random number generator. Random number generator, you actually need to include the std library, std integer.h, and the time.h. Time give you the random time, okay? And then you need to call the function of srand, seed for the random number. And there is a constant called random maximum that you need to know. Okay, so you include these different things, then there is a random function, random integer function, and random range function. So reset random number function, you do srand with time null. Okay, that will reset your random number generator. And then if you want to calculate the random number, you use a rand that will generate a random integer divided by maximum value plus 1. That will be a 0 up to 1, but not including 1. It's okay? Here we have a plus 1.
Yeah.
Okay? This will give you the random function that you need as Java. And then you use a random times maximum, okay, and then divide by 32-bit. That actually is your random 32-bit integer. So this random number we teach you in Java, so we don't repeat, okay? And then formatted print we teach you already, so this one we don't repeat. You can start it similar, okay? Escape sequence is the same. Any questions so far for this chapter?
No.
Okay, that's it for today, okay? Thank you.
All right. Bye, Mr. Cho. Have a
Okay.
great day.
You too, bye-bye.